Hello friends and welcome to your channel GATEquestionsECE. So I am back with next question on this series of random variables and the question code is 112. If continuous random variables z, x1, x2 and x3 are related by z is equal to minimum x1, x2, x3 where x1, x2, x3 are independent and identically distributed i.i.d random variables, then which of the following is true for the PDF of z? So we will have to find out of these four statements which one is true. We have done a similar question number 111, in which it was given z is equal to maximum x1, x2 and x3. So on the similar lines we will solve this question. So let's see its solution. To solve this problem, I will like to recall the end results of question number 108 and question number 110. So the end results of question number 108 and 110 was that if x1, x2, x3 are three continuous random variables and z is equal to minimum among x1, x2, x3, then the CDF of z will be equal to the sum of marginal CDFs of x1, x2, x3, that we can write f x1 z plus f x2 z plus f x3 z minus the joint CDF of x1, x2 up to sample values z, z minus the joint CDF of x2, x3 z, z minus the joint CDF of x3, x1 z, z plus the joint CDF of all three random variables x1, x2, x3 for same sample value z, z and z. So that was the end result when x1, x2, x3 are continuous random variables and z is equal to minimum among x1, x2 and x3. So let's see how this result will modify if x1, x2, x3 are independent. So if x1, x2, x3 are independent random variables, mutually independent random variables, then we can write that the CDF of z, here I am dropping this z and bracket for the simplicity of writing. So the CDF of z will be equal to CDF of x1 plus CDF of x2 plus CDF of x3 minus the product of marginal CDF of x1 with the marginal CDF of x2 minus product of marginal CDF of x2 with the marginal CDF of x3 minus the marginal CDF of x3 and marginal CDF of x1 plus the product of marginal CDF of x1, x2 and x3. So this is the result if they are independent. This is true even if they are dependent. Moreover, if x1, x2, x3 are independent and identically distributed, which we call as i.i.d, i, I and d. So for this case, we know we can write that CDF of x1 will be equal to CDF of x2 and which will be equal to CDF of x3. All these CDFs are equal. So we can easily write that the CDF of z in this case will be 3 times fx1. In place of x2 and x3, I am writing fx1. Similarly, minus, so this will become 3 times fx1 square and plus fx1 cube. So this is the result for independent and identically distributed random variables x1, x2, x3. To obtain the PDF of z, we can differentiate this equation on both sides. So differentiating both sides, we get the differentiation of CDF of z will be the PDF of z will be equal to 3 times differentiation of this. This is the CDF of x1. So differentiating it with respect to z, we get f x1 of z minus differentiation of this. So differentiation of this will be 6 times the CDF of x1 into the differentiation of CDF of x1 with respect to z. So differentiation with respect to z will be the PDF of x1 plus differentiation of this term. So this term's differentiation will be 3 times the CDF of x1 square into differentiation of the CDF of x1, which will be the PDF of x1. So this is the final answer to this question. So the correct option is option 4.